Hi everyone. Today let's see one of the favorite semester exam question paper sum, that is a rectangular box open at top is to have a volume of 32 cc, that is cubic centimeter. Find the dimension of the box that require least material for its construction. See, this is the practical sum. If you are a owner of some company, we have to put our material inside the box so that the volume should be more and the surface area of the material should be less, because the price we will get is for the volume and the amount we will invest, that is for the material. Okay, so let's start this sum. So solution. So the condition they have given us, volume should be 32 cc, and we have to find the dimensions of the open box so that we can use the least material. So how we have to start this? Let us assume the dimension of this material as x be the length, y be the breadth, and z be the depth. So the given condition is volume is 32. So what is the volume of this box? X into y into z is equal to 32. And what is the another thing we have to find in this is the surface area of this box. So what will be the surface area? So the surface area, so this is volume, and another one is surface area. So the box is open at top, so totally a cube will be having 6 surface, 2 in the front and back, 2 both sides, and 2 in the top and bottom. So we have 6 sides. Since the box is open at the top, we have 5 surface. So what is the bottom surface area? That is the surface below this, that is x into y. And the side surfaces y into z, 1, and that side also will have the same. So this will be plus 2 y z. Similarly in the front and back it will be x z, so that is 2x z. So this is the surface area. Xy for the bottom, 2yx for the right side and left side, and 2xz for the front side and back side. So this is the surface area. See, in this kind of sum we have two things: what they have given, that is a constraint, and what we are going to find is a function. So here we are going to find the surface area. So this is the function. So what is the function? We are going to find the surface area. So f, the function is xy plus 2yz plus 2xz is the function. And what is the constraint? What is a given condition? That is known as constraint. We can write it like this: constraint is xyz. If we take 32 on this side, it should be minus 32. So xyz minus 32, that is the constraint. So in this we have to apply auxiliary equation. So what is the formula for auxiliary equation? Is g, that is equal to f plus lambda constraint. Okay, so that is equal to, what is f? F is nothing but xy plus 2yz plus 2xz. This is f. And what is constraint? That is xyz minus 32. So finally we can write this as xy plus 2yz plus 2xz plus lambda xyz minus lambda 32. 2. And this is what we have to do. We have to partially differentiate this equation with respect to x, with respect to y, and with respect to z. So we know that if we are partially differentiating with respect to x, y and z are constant. If you are partially differentiating with respect to y, x and z are constant. If you are partially differentiating with respect to z, x and y are constant. So first what we will do, we will partially differentiate with respect to x. So if we do with respect to x, y is constant, so differentiation of x will be 1. There is no x, so completely everything is constant, so this will be 0 plus this will be 2z is constant and differentiation of x will be 1, and for this lambda yz are constant, differentiation of x will be 1 and this will be 0. So this can be written as y plus 2z plus lambda yz, and in this we have to equate gx is equal to 0. So ultimately what happens, we have y plus 2z, that will be equal to minus lambda yz. So from this we have to find what is minus lambda. So we'll get y plus 2z, that is equal to minus lambda, and yz will come down. So this is equation 1. In the similar fashion, what we have to do, we'll take this equation and we have to again differentiate partially with respect to y and z. So we'll take that g equation, that is g, that is equal to xy plus 2yz plus 2xz plus lambda xyz minus lambda 32. What we are going to do, we are going to differentiate with respect to y. So this will be x is constant, y is 1, and 2z is constant, y will be 1, and no y, so this will be 0, and this will be plus lambda xz is constant, y will be 1, and this will be 0. So what we will do, we will equate this x plus 2z plus lambda xz is equal to 0. So we can write it as x plus 2z plus lambda is equal to, if it goes that side, it will be minus x lambda. So what we are going to find, minus lambda, so x plus 2z by z is equal to minus lambda. Let this be equation 2. So similarly we have to do partially differentiate with respect to z. If we do with respect to this z, this will be 0, this will be 2y, and this will be 2x, and this will be lambda xy, and this will be 0. So ultimately we can equate this to 0, that is 2y plus 2x plus lambda xy is equal to 0. If it goes that side, it will be 2x plus 2y, that is equal to minus lambda xy. So 2x plus 2y by xy will be equal to minus lambda. So ultimately we got 3 equations, all are minus lambda, so we can equate all the 3 equations. So what was the first equation, y plus 2z by yz, so we can write it as y plus 2z by yz, that is equal to, second equation, x plus 2z by xz, and the third equation 2x plus 2y by xy. So what we have to do, we have to take any two equation and we have to solve. So let's take the first two equation. What is the first two equation? Y plus 2z, just make a bracket, it will be convenient for you, divided by yz, that is equal to x plus 2z divided by xz. So we have a x here, we can cancel it out. So we have to cross multiply, that is xy plus 2xz is equal to xy plus 2yz. So we can cancel it out, xy. What else is remaining? That is 2xz is equal to 2yz. We can cancel it out, 2z and 2z. We have ultimately x is equal to y. Now what we have to do, we have to take another two equation, that is x plus 2z divided by xz, that is equal to 2x plus 2y by xy. So what we can cancel in this, we can cancel it out, the x on both sides, so we can cross multiply this. So xy plus 2yz will be equal to 2xz plus 2yx. When you are multiplying, what you do, first write x, then write y, and then z. So in this we have 2yz on both sides, so we can cancel it out. So xy is equal to 2xz, so we can cancel it out, x. So finally we have y is equal to 2z. So we have x is equal to 2y and we have y equal to 2z. So finally we can write the equation as x is equal to y, that is equal to 2z. So whatever may be the open box sum, so we have this equation, that is x is equal to y is equal to 2z. So finally we have the condition. What was our condition? Our condition is volume is xyz, that is equal to 32. And what is x? We write x as x, and just check, we can write x is equal to y and y is equal to 2z. So we have to write everything in terms of z. So what we will do, we will write everything in terms of z. So what is x? X is equal to 2z. What is y? Y is equal to 2z. Z, we can write it as z, so that is equal to 32. So we can write 2 into 2 is 4. Z cube is equal to 32. So 4 8s are 32. So what will be z? Z will be, z cube is 8, then z will be equal to 2. So if z is equal to 2, what about x and y? We have the equation, that is x is equal to y is equal to 2z. So what about x? X is equal to 2z, that is in the sense 2 into 2, that is 4, and y is also equal to 2z, that is 2 into z is 2, that is 4. So we got all the three dimensions, that is the dimensions of the box are 4 centimeter by 4 centimeter by 2 centimeter. Okay, so whatever may be the open box sum, the general equation will be x is equal to y is equal to 2z. When we substitute this, we will get the answer. Okay, so this is one of the important sum in this unit. So make sure you know the formula, and the shortcut of this is, the general equation will be always x is equal to y, y is equal to 2z. Okay, and you can substitute in the condition formula, whether it is volume or surface area. Okay, that's all for today.